Imagine this. You walk up to a Tesla. Sleek, silent, smart. A masterpiece of modern engineering. But what happens if someone takes that perfect electric shell and sends 120 volts straight into the body of the car? Sounds impossible. Sounds insane. Sounds like the kind of thing that should never happen in real life. And yet, this experiment can reveal something that almost no Tesla owner thinks about. Something that every electrician must know. And something that could save a life. Before we dive in, hit like and subscribe right now. Because what you are about to hear is a story that blends curiosity with danger. Science with real-world consequences. And trust me, you do not want to miss what happens next. So let's begin with the heart of the question. What really happens if the outer body of a Tesla becomes energized? To understand this, we have to step away from the shiny paint and the futuristic screens and go deep into the core, ideas of grounding, bonding, and electrical return paths. These principles keep every electric car safe on American roads. But when they fail, or when someone intentionally injects voltage where it should never be, the entire equation changes. A Tesla is not like a traditional gasoline car. It is a rolling computer with a massive battery pack. It has high voltage systems that operate far above anything you use in a regular home. But here is the twist. Even though the internal systems run at powerful levels, the body is designed to stay at neutral potential. No shock, no danger, safe to touch. That is how it is supposed to be. But what if an external source forces 120 volts onto that metal surface? Suddenly the car becomes a conductor, and the question becomes simple. Does the voltage stay on the shell? Does it trip a breaker? Does it ground out instantly? Or does something far more unexpected happen? To understand the reaction, picture the Tesla sitting on dry pavement. Rubber tires, no grounding point. The body is now floating electrically. When voltage hits a floating object, it does not behave the way people assume. You could touch it with one hand and feel nothing. You could get dangerously close and still be unaware the entire shell is loaded with energy waiting for the right moment to escape. But the danger appears the second a complete path is formed. A puddle, a metal tool, a human hand touching the car while standing on wet ground. The moment a return path becomes available, the energy inside the system surges forward. That is when a shock becomes not only possible but likely. And here is where electricians will lean in. Because the real question is not just what voltage does to a vehicle. The question is what the breaker or safety device on the power source does. Will a ground fault interrupter trip instantly? Or will the current remain stable enough to create a dangerous condition? In a real-world scenario, the answer depends on moisture, resistance, grounding, and the size of the power supply feeding the voltage. For most American households, a 120-volt line connected improperly or maliciously to a car's body could energize the entire shell without tripping anything at all. It might look normal. It might stand there silently. But the risk is absolutely real. That is why grounding and bonding exist, and why electricians insist on testing metal structures before touching them. Now, imagine a human walking up to the car with keys in their hand. They reach for the door handle. Their shoes are wet. They are standing on ground that conducts electricity. The moment they make contact, there is a lightning-like arc that tries to equalize the potential between their body and the Tesla. That is the shock moment. And depending on the conditions, it can range from mild to severe. Even more interesting, Tesla systems can detect unusual electrical behavior. If the voltage penetrates deeper into the car's electronics, internal safety systems may isolate circuits or shut down high-voltage components. But those protections are designed for internal faults, not for someone feeding outside electricity into the shell. Now let us talk about the part that affects every viewer. Whether you are a licensed electrician or just someone who drives to work every day, the lesson is simple but powerful. Electrically energized metal is silent. It does not glow. It does not spark. It does not warn you. It waits. That is why safety testing matters. That is why grounding matters. And that is why people who work around electricity know that assumptions are dangerous. When dealing with energy, you test first and touch second, not the other way around. So what would really happen to a Tesla if 120 volts were applied to its body? It might quietly energize without visible signs. It might shock the first person who provides a path to ground. It might trigger a protective device, or it might simply sit there holding a dangerous charge like a trap you cannot see. This is why electrical knowledge is not optional. It is essential. And this is why the content on this channel exists. To help electricians, to help homeowners, to help anyone who interacts with electricity in any form. Whether you understand circuits deeply or you are hearing these concepts for the first time, this matters to you. If you want more breakdowns like this one, more real-world tests, more explanations that reveal the hidden dangers and hidden beauty of electrical engineering, then make sure you hit like right now. Subscribe so you never miss our next investigation. And drop a comment telling us what experiment you want to see next. Because the world is full of questions no one dares to ask. We are here to answer them. And the next one might change everything you think you know about electricity.